Hello everyone, I'm Byungmin Kim from Triple IXR Lab. Today I'll present the paper Value of Information, a framework for human agent communication. As language model agents become more capable, they are increasingly expected to interact with users, interpret incomplete requests, and make decisions on their behalf. In many real-world tasks, however, the user's intent is not fully specified from the beginning. Important preference, constraints, or goals may remain hidden. In this situation, the agent faces two undesirable extremes. The first is to act immediately without clarification. This is efficient, but the agent may overlook a hidden preference and take a misaligned action. The second is to ask about every possible preference. This may prevent some errors, but it creates excessive interaction burden and makes the agent frustrating to use. Therefore, the key challenge is not simply whether the agent can ask questions, but when asking is actually worthwhile. However, the right balance is not the same for every task. In an animal guessing game, the cost of one more question may be greater than the cost of making a harmless mistake. In medical diagnosis, however, an incorrect decision can have much more serious consequences, so the same level of uncertainty may justify asking another question. This is why confidence alone is insufficient. Confidence describes uncertainty, but it does not capture the consequence of an error or the burden placed on the user. The ask or act decision must therefore account for uncertainty, task risk, and interaction cost together. This creates a fundamental dilemma for the agent. If it stops too early and acts, it may miss a decision-relevant preference and make a misaligned choice. For example, a user may require a non-stop flight, while the agent recommends a cheaper connecting itinerary. On the other hand, if the agent continues asking, the user's interaction burden keeps increasing. In other words, the agent must balance the risk of acting with incomplete information against the cost of requesting more information. The paper addresses this dilemma through value of information (VOI). The key question is whether the expected improvement from one more clarification question is greater than the cost of asking it. So the paper makes three main contributions. First, it formulates adaptive human-agent communication as a decision theoretic problem based on query ambiguity, task risk, and cognitive load. Second, it proposes a practical inference time (VOI) method that allows an LLM agent to dynamically choose between acting and asking for clarification. Unlike fixed dialogue rounds or manually tuned confidence thresholds, the method evaluates whether a question is worth its communication cost in the current context. Third, the paper validates this framework across several domains and shows that it consistently improves utility without requiring task-specific threshold tuning. Now I'll examine the method using the flight example. The user only says "fly to London," while the hidden preference is a non-stop itinerary. If the agent acts using only its current belief, if it may choose a cheaper connecting flight. Importantly, this action can still be optimal under the information currently available to the agent. The failure occurs because the belief itself omits a relevant preference. In other words, the baseline is not necessarily reasoning irrationally. It is making a rational decision from an incomplete belief. This motivates evaluating whether a clarification question could improve the downstream choice. This slide explains how the agent estimates the value of asking a question before actually receiving the user's answer. Since the answer is unknown, the agent considers several possible response branches. For each branch, it first predicts the probability of that answer. The answer then updates the current belief to a posterior belief, and the agent selects the best action under that updated belief. In this example, the three possible answers occurs with three probabilities, and their corresponding optimal action values are 6, 7, and 9. The expected post-question value is therefore the probability-weighted sum of these posterior values, which is 7.7. The important point is that the method does not value a question simply because it reduces uncertainty. It values a question only when the possible answers are expected to lead to better downstream actions. We can suppose the expected value of acting immediately is 5.0. If the agent asks a clarification question first, the expected post-question value rises to 7.7. Asking is not free, however, so we subtract a communication cost of 0.5, which equals positive 2.2. Because this value is greater than 0, the agent should ask, identify the nonstop preference, and then commit to an action. The important point is that the framework does not reward asking by itself. It asks only when the expected improvement in the final decision is large enough to justify the interaction cost. So the full method can be understood as an ask or commit loop. First, the request and interaction history define the current belief B. The agent then evaluates the value of acting immediately. In parallel, it evaluates candidate questions by simulating possible answers, forming posterior beliefs, and estimating the value of the resulting actions. The expected improvement is reduced by the communication cost to obtain net VOI. If the maximum net VOI is positive, the agent asks the corresponding question, adds the answer to the history, and updates its belief. If no candidate question has positive net value, the agent commits to the best action under the current belief. The experiments cover 4 domains with different ambiguity patterns and decision states. Animal guessing is a relatively low-stakes question answering task, while medical diagnosis represents a setting in which incorrect decisions are much more costly. Flight recommendation and web shop connect hidden user preference directly to an external action. The authors evaluate the framework. This diversity is important because the goal is to show that VOI is not a task-specific heuristic, but a general communication rule that can operate across different forms of uncertainty and different consequences of error. This figure shows the trade-off between asking more questions and paying a higher communication cost. The x-axis represents the number of clarification rounds, while the y-axis shows the final utility after subtracting question costs. The top row uses a low communication cost, so asking additional questions can still be beneficial. The bottom row uses a higher cost, so excessive questioning reduces the final utility. The purple and orange curves show fixed round and confidence-based base signs under different manually selected settings. The red star represents the operating point chosen automatically by VOI. The main result is that VOI adapts its stopping behavior to the task and the communication cost. It asks more in tasks such as mixed training questions, where information is highly valuable, but stops earlier in flight recommendation or web shop when additional questions are less beneficial. Therefore, VOI does not simply minimize the number of questions. It tries to maximize overall utility. The main takeaways is that asking should be treated as a decision, not as a fallback behavior. Uncertainty alone does not tell us whether clarification is useful. A question is valuable only when it improves the expected final action enough to justify the communication cost. VOI formalized this trade-off by comparing the value of acting now with the expected value after asking. If the maximum net VOI is positive, the agent asks. Otherwise, it acts on its current belief. Therefore, the paper shifts the focus from "Am I uncertain?" to "Is asking worth it?" However, the framework relies on several simplifying assumptions. Its decisions depend on the quality of the LLM's belief and response estimates, so inaccurate probabilities can lead to incorrect VOI calculations. The communication cost is also modeled as a fixed cost per turn, although real user burden varies depending on the complexity of each question. In addition, candidate questions and actions are predefined, and evaluating multiple questions and possible responses increases inference cost. VOI is therefore not yet a complete solution for real-world communication. Still, its central insight remains valuable. An agent should ask only when the expected value of information exceeds the cost of obtaining it. This is the end of my presentation. Thank you for listening.